Welcome back for our Algebra 2 lesson for 1-3. Today we're going to talk about algebraic expressions. Now that means two things. So our two learning targets for today. You're going to evaluate algebraic expressions and you're going to simplify algebraic expressions. So when writing a mathematical expression from a word phrase, so here we're going to start dealing with a couple word problems, okay? Taking an expression, taking a sentence out of words and making a mathematical expression out of it. So the first thing to do is identify the vocabulary that identifies an operation. So for example, the word sum or total, you can add total to your list. You're going to be talking about addition. Subtraction, if you're talking about less than, fewer, difference. You're talking about subtraction. Multiplication, product or times. For division, you're talking about quotient. All right, so you always begin by identifying the vocabulary that tells you operations. Then you decide what order those operations have to occur in. So for example, which algebraic expression models the word phrase 7 fewer than a number t? So we want 7 fewer than t. So fewer than. So hopefully you can pick up on the fact we're talking about subtraction. Now the big thing here is to make sure that we're subtracting the right way. So 7 fewer than t means we're starting with t and we need 7 fewer than that. 7 less than t. So make sure you're very cautious. Think through your mind what the words are saying. Fewer than means you're going to flip the order from the way that it's written in the sentence. All right? So again, you can tell that because of the word than. So if you want to circle that or something, to remind yourself that that word is going to flip the way that you write it. Okay? 7 fewer than t means you take t, subtract 7. And what about this? Which algebraic expression models word phrase 2 times the sum of A and B? All right, so here we have multiple things happening. I see times, which is telling me to multiply, and I see sum, which is telling me to add. Now the question is, which do I do first? Well, if I want 2 times that sum, it means I need the sum first, right? So in this case, I need to start with the sum because I'm going to take that sum and now I'm going to multiply that whole thing by 2. Well, how do I represent multiplying the whole thing by 2? Well, I need parentheses around it to tell myself, hey, that's happening first, and then multiply by 2. And I guess here I never actually showed. Here the answer would be C, and in this one, actually ironically, the answer is also C. All right, so let's flip the page to model a situation using an algebraic expression. Identify the actions that suggest operations. So kind of the first step we did in the last one, okay? Then you want to define one or more variables to represent the unknowns and represent the actions using variables and the unknowns. All right, so kind of wordy. However, let's take a look at what it means. So you're on a bicycle trip. You've traveled 52 miles the first day. Since then, your average rate has been 12 miles per hour. What algebraic expression models the distance you've traveled so far? Now, there's one thing I would add to this, just mentally to help you. What you're really looking for is the total distance. So even though it's not written there, it's kind of the idea of reading between the lines, right? You want the total distance. Total means adding. All right, so I know I'm going to be adding something here, adding two somethings to be more precise. So the first day, day 1, it says 52. You went 52 miles, exactly. All right, 52 plus what? Well, 12 miles per hour. okay? So 12 miles per hour. So that is introducing a variable, isn't it? There's something we don't know. That something we don't know is the number of hours. So I'm going to let h represent my number of hours. So if I go 12 miles per hour, that means after 1 hour, I would go 12 miles. After 2 hours, I would go 24 miles. After 3 hours, I would go or have gone 36 miles. So hopefully you can see that language, that 12 miles per hour. What that language per hour is telling me to do is multiply those together. Because for every hour, I'm going 12 more miles. Okay? So my expression would be 52 plus 12h. All right, how about this? You had $150, but you are spending $2 each day. What algebraic expression models this situation? All right, so what's happening? Well, we're starting with $150 and we're spending how much? $2 each day. Well, spending implies that we're going to take how much money we had and we're having less, all right? So we have to subtract off $2 for each day. So we're introducing the variable. What do we need? Well, we need the number of days. That's what we don't know. Now, this is very similar to that biking example, $2 for each day. Well, so after 1 day, that means I spent $2. After 2 days, it meant I spent $4. After 3 days, it meant I spent $6. So that's another example of that vocabulary, each day. So $2 for each day means I represent it like that. I represent that via multiplication, and we're subtracting it off of the total from the money that we started with. All right, so once we understand this concept of how to create expressions, then it comes in the idea of evaluating expressions. Now, to evaluate these expressions that we're writing, it means you subtract the given value in for the variable and calculate using the order of operations. Now, what you've learned since maybe even the 6th grade, I'm not sure how young this starts, but you start, oh, sorry, guess I can't just move the word PEMDAS. You start learning PEMDAS. Now, the P meaning parentheses, E meaning exponents, M and D, remember, happen simultaneously, multiplication and division. They work from left to right. And then AS is addition or subtraction. So remember, that's the order that you do all of these things in, okay? The order that you will calculate things when you're evaluating expressions. So let's dive in and get some practice, shall we? So, evaluating expressions. Again, think PEMDAS. Now, what I'm going to tell you, something that will help you down the road. Today, it may seem a little bit silly and unnecessary a lot of the time. However, something that I am going to tell you that is going to be very, very helpful is whenever you're evaluating, whenever you see the word evaluate, I want you to use parentheses around the number you're putting in, okay? Again, today you may not see much value in it, but I promise you, come chapter 4, you really, really will. Okay, so just make sure you get in that habit now so you're a master at it by the time we get to chapter 4. So 7 times a plus 4 plus 3b minus 8, and they're saying let a be negative 4 and let b be 5, and they want us to evaluate that. So I'm going to write that out. And again, I'm going to put extra parentheses any time I put a number in. Okay, so anytime I put a number, notice I put parentheses around it. Wherever the A was, I put a negative 4. and where the b was, I put 5. Now, something I do want you to note, those parentheses I've added in, those don't really play out in order of operations. They're just kind of protecting the number that you put in. And you'll see why come that second example. Actually, come the third example. All right, so order of operations, we're going to start with parentheses. And again, when I say parentheses, I don't mean the ones I just put in. I mean the overall parentheses from the original problem. So in the original problem, the overarching parentheses were here. -4 plus 4. So -4 plus 4, I'm going to do that first. Now I'm going to get 0. So dealing with parentheses leaves me with that. Again, ignoring the ones I started the problem with. The ones that don't have any operation within, you ignore for now. All right, next, exponents. Well, awesome for us, there aren't any. So multiplication and division. Well, I only see multiplication. And again, multiplication occurring from the left to the right. So that means I end up with 0, then 3 times 15, or sorry, 3 times 5 is 15, then -8. Finally, addition and subtraction going left to right. 0 plus 15 is 15, -8 ultimately gives you 7, and that is the end of our problem. All right, so again, not too horrible, just making sure you keep track of PEMDAS. Go in the right order of things. All right, let's try our next one. X over y plus y squared, and we're going to have x equal 1 and y equal 1/2. So again, it may seem silly at the moment, but I really want you to carefully put in those parentheses. So I have all those in, and now I start thinking order of operations. P for parenthesis. Well, there's nothing happening here where there's an operation within a parenthesis. So I'm not going to worry about that, okay? But I do have an exponent, okay? Now, again, notice the parentheses around my 1/2. When you're typing that into the calculator, you want to make sure that you do the same thing. Put the 1/2 in parentheses and then raise it to the second power. Again, great time, type it into your calculator. Make sure you know how to work that square button, that you know how to do powers. If you don't, ask me when you get back to class. So when you deal with that power, you're going to get 0.25. 1/2 squared is 0.25. All right, so we've dealt with that. Now we're dealing with the 1 divided by 1/2. And again, this is another example where those parentheses are necessary. Use them when you type it in. If you don't, you're going to get it wrong. So another great self-check. Have the calculator out right now. Make sure you're getting what I'm about to tell you. And if you don't, come and ask me in class. So 1 divided by 1/2. You type that into the calculator, you actually get 2. Again, if you aren't getting that when you type it in, please see me for help. Then finally, 2 plus 0.25 is 2.25. And there's the end. And our last case. So we're letting x be 6, y be -3, and again, make sure you're putting parentheses around the numbers that you're plugging in. So putting parentheses around the numbers I'm plugging in gives me that. Now, again, be very cognizant of this. So the first thing is parentheses. Well, there is a parenthesis with operations inside of it, okay, within here. But notice, even within that parenthesis, there's 2 operations happening. You're squaring and you're subtracting. So again, what do we do first? We deal with the exponent first. So if you go inside of a parenthesis and there's multiple operations, you follow the order of operations within the parenthesis first. All right? So that means here I get 36. Here's another place. Putting the parenthesis around the original numbers makes a difference. Try this right now in the calculator. -3 squared. And I guarantee you, if you don't have the parentheses there, you're not going to get what you should. And you should get 9. As you know, a negative times a negative is positive. But your calculator without those parentheses is going to do something different to you. So make sure you put those parentheses there if you're using a calculator. Otherwise, just use your common sense knowledge. -3 times -3, negative times a negative, you should know gives you a positive. And now finally, I can take care of that parentheses. So 36 minus 9 gives me 27. Now all I have left is multiplication and division. Now there really is no working left to right, so I'm just going to take care of the top of the fraction and then the bottom of the fraction. Okay, so top of the fraction gives me 54. I divide that by 3, gives me 18. So this one is a little bit more involved, but a really wonderful example of making sure that you're following those order of operations. All right, so next page, we're going to work on not only making our own expressions, but then evaluating our expressions. So ticket prices for admission to a museum is $8 for adults, $5 for children, $6 for seniors. What algebraic expression models the total number of dollars? There's that word total. Total tells me I'm going to add up the money for adults, the money for children, the money for seniors. So I'm going to have a lot of adding happening here. Now there's some things that I don't know, okay? I don't know the number of adults. So I'm going to call that A for the number of adults. I don't know the number of children. So I'm going to call that C. I don't know the number of seniors. So I'm going to call that S. And again, big picture here is we need to figure out how much money for each. So $8 each for every adult ticket. Well, hopefully you're picking up that word each, for, per. Things like that represent a multiplication. How much money are we making on the adults? Well, $8 per adult. How much money are we making for the children? $5 per child. How much money are we making on the seniors? Well, $6 per senior. All right, so hopefully you can see where that expression is coming from. And now part B is basically asking us to evaluate that. If 20 adult tickets, 16 children's tickets, and 10 senior tickets are sold, how much money is collected? All right, so I'm going to plug those in the appropriate places. Now you follow order of operations. So 160, 80, and 60. Now we add those all up. That's going to be $300 that they made that particular morning. All right, how about in basketball? Teams can score by making 2-point shots, 3-point shots, and 1-point free throws. What algebraic expression models the total number of points? There's that word total again, meaning addition. So we're going to be adding up how many points. And hopefully you're seeing this pattern again. So 2 points per 2-point shot. Well, we don't know how many of those there are, so I'm going to call that A for the number of 2-point shots, B for the number of 3-point shots, and C for the number of free throws. And what am I going to do? Well, I get 2 points per 2-point shot. So what does that mean? Well, That means I'm going to make 2 times A. I make one of those, I get 2 points. I make 2 of those, I get 4 points. Should make sense. Same thing for the 3-point shots. It's going to be 3 times the number that you make. You make 1, you get 3 points. 2, you get 6 points. And then 1 times the number of free throws that you make. And let's evaluate that. So if a team makes 10 2-point shots, 5 3-point shots, and 7 free throw shots, what does that add up to? 20 plus 15 plus 7. That is going to give us 42 points in all. All right, flip the page. We're getting closer to the end. We need to talk about simplifying expressions now. Here, I'm basically just going to fly through these for you, okay? And if I'm going too quickly, you can always pause the video to make sure you're writing in everything that I have here. But again, I'm just going to fly because these traditionally just make sense, okay? I just want them in your notes in case you need to reference them. Definition of subtraction. In an equation, it means you can subtract. It's the same thing as the opposite of adding. Definition of division. While dividing is the same thing as a fraction or the reciprocal, multiplying by the reciprocal. However, just make sure you're not dividing by 0. Distributive property, you already know. Anything multiplied by 0 gives you 0. Multiplying by -1 just makes whatever you started with negative. Opposite of a sum, well, that negative will distribute to both pieces of that sum. That's something that's very important, is to notice the distribution of that negative. Opposite of a difference, again, think just a distribution. That second thing will actually turn positive. The opposite of a product means either thing could be considered the negative. Opposite of an opposite, the negative of a negative, is going to become positive, all right? And those all become important when we start talking about simplifying expressions, which we're going to do quickly on the next page. So the biggest key when it comes to simplifying expressions, not only that list that we just quickly went through, but combining like terms. Now, like terms means same variables to the same powers. All right, very, very important. So let's take a look. 7x squared plus 3y squared plus 2y squared minus 4x squared. And we're talking about combining like terms. We're combining things that have the same variable to the same power. Power meaning exponent. So here I have a 7x squared and I see a negative 4x squared. So 7x squared minus 4x squared. So I'm starting with 7 of them and I'm subtracting 4. So that's going to leave me with 3 of them. And what do I mean by them? Well, those x squareds. That's why same variable, same power. Just perform the operation. 3y squared and 2y squared. So 3y squared, and I'm adding 2 more. So 3 plus 2 is positive 5. And we're talking about y squareds. Same power, same variable. All right, now this next one is a little bit more complicated, okay? Because if you notice, there's a little bit more happening here. Notice there's some distributing to do first, all right? So I'm going to take that negative to the 3k, so that's going to give me a negative 3k and a negative m. Remember that negative ends up applying to both things. You basically just distribute it. Just like I'm about to distribute the 2. 2 times k 2 times negative 4m. Well, 2 times negative 4 will give me negative 8m. And now I have some like terms to combine. So I have k's, so negative 3k plus 2k. Well, negative 3 plus 2, I'm still left with a negative 1k. But again, you don't have to show the negative 1 there. The 1 can kind of be hidden. And then I have negative m minus 8m. So think, there's a hidden 1 there, so negative 1 minus 8 more. And again, if that's confusing or scary, type it into the calculator. But you're getting more negative. That is actually negative 9 of those m's. So you get negative k minus 9m. And our last example. Here I see negative 4j squared. And there's another term with a j squared. And again, think of that as a 1. So negative 4 plus 1. So here we're adding on. We're going to be getting closer to being positive. Negative 4 plus 1. Again, make sure you're getting negative 3. Again, use your calculator if all else fails. Now, notice I did not include the 5j. Because you may have the same variable there, but you don't have it to the same power. So that's why the 5j has to stay on its own, and then this negative 7k has to stay on its own. All right, you can't combine those because they're not the same variable to the same power. They have to stay separate. All right, we've made it through another lesson. So that means I want you to quickly write a summary for me. So take a couple minutes now that you finished, and I want you to write that summary for me. All right? So what that means is I need you to quickly reflect on what we talked about, or reflect on any questions you still have and want to ask me tomorrow. So get on that, and then I will see you tomorrow to check your summary.